Experts from Google DeepMind, in collaboration with scientists, have developed a new AI tool called Ithaca, which is designed to decode damaged ancient Greek inscriptions. The system is based on Pythia, a tool for text restoration, and allows not only the reconstruction of text, but also the determination of its region of origin and date of creation. Previous similar systems required further refinement as they provided numerous contextually fitting words, leaving scientists to manually select the appropriate options. Google addressed this limitation and advanced their development, enabling specialists in ancient Greek inscriptions to save significant time working with damaged texts. Initially, the Google DeepMind team focused on converting the largest collection of ancient Greek inscriptions into machine-readable text, comprising about 35,000 inscriptions with a total of 3 million words. Subsequently, programmers trained the system to suggest replacements for missing letters and words. Additionally, they enhanced the system by adding the capability to identify the region of origin and possible date of creation of the text. This marked the creation of Ithaca. Remarkably, testing Ithaca demonstrated fantastic results. The system can independently restore damaged texts with an accuracy of 62% in a short amount of time. When working collaboratively with historians and linguists, this accuracy increases to 72%. Without a doubt, this innovation will significantly aid scholars in reconstructing ancient Greek texts with remarkable precision. In 2016, archaeologists in Florence discovered the ruins of an ancient Etruscan temple built around 2,000 years ago. Among the remnants of the temple was a long stele with religious inscriptions. This discovery was sensational, as scholars had never before uncovered religious artifacts featuring Etruscan script. The stele could help reveal more about the religion of this civilization, but deciphering the inscription was necessary. The Etruscans were an ancient civilization inhabiting the northwestern part of the Italian peninsula in the 1st millennium BCE. Today, this region is known as Tuscany. The Etruscans were a highly developed civilization. Surprisingly, the ancient Romans borrowed many of their construction technologies, burial rituals, gladiatorial games, and more from the Etruscans. Despite this, the Etruscans were eventually entirely displaced by the Romans. Excavations in Tuscany over many years have provided significant information about this vanished civilization, though some aspects of their life remain unknown. Studying their writing could help fill these gaps. In 2022, programmers from the Massachusetts Institute of Technology proposed creating an algorithm to decipher the text on the discovered Etruscan stele. Initially, scholars were skeptical, but they eventually agreed, and the development process began. Now historians have a chance to learn more about the gods the Etruscans worshipped. The Akkadian language, also known as the Assyro-Babylonian language, is one of the oldest Semitic languages, spoken by the inhabitants of ancient Mesopotamia, the Akkadians, Babylonians, and Assyrians. Although the language has been studied extensively, deciphering Akkadian cuneiform texts remains time-consuming. To address this issue, in 2020, a team from Tel Aviv and Ariel universities developed an algorithm capable of translating Akkadian cuneiform into transliterated Latin script. The algorithm proved highly effective, achieving a performance level comparable to that of machine translation for modern languages. However, scholars did not stop there. In 2023, Israeli programmers unveiled a new AI model capable of translating Akkadian cuneiform into both Latin script and English within seconds. Scholars believe this model has the potential to revolutionize the study of ancient history. Recently, archaeologists discovered several hundred clay tablets with Akkadian cuneiform. And thanks to this new translator, they can now quickly obtain translations of these ancient texts. The Enigma cipher machine, patented in 1918 by German engineer Arthur Scherbius, was widely used by the German military during World War II. Enigma was considered an unbreakable machine, and for a good reason. Its polyalphabetic substitution cipher, 4-rotor scrambler, and 10 plugboard connections enabled 151 trillion permutations and combinations. However, British mathematician Alan Turing, with the help of mathematicians, logicians, and the Polish intelligence service, which had cracked an earlier version of the Enigma code, managed to break the code of the advanced model. It took Turing nearly a year to accomplish this. In 2017, a team of British programmers decided to replicate Turing's success by cracking Enigma's code using artificial intelligence. Unlike traditional methods, the program compared encrypted messages to a database of German words and identified linguistic patterns to produce decrypted text. The process took the computer only 10 minutes, and this algorithm has since found applications in various fields, including medicine. In May 2024, Turkish Deputy Minister of Culture and Tourism, Gürkan Yazgı, announced that Turkish scientists were actively working on deciphering 2,000 Hittite tablets using artificial intelligence. The Hittite Empire was an ancient state in Anatolia, located in present-day Turkey, that existed over 3,000 years ago. The empire's peak occurred in the 14th century BCE, but it ceased to exist after the 1180s BCE. The new project was implemented in several stages. Initially, specialists digitized Hittite cuneiform tablets stored in the Museum of Anatolian Civilizations in Ankara and the archaeological museums of Istanbul. This step also enabled the creation of an open-access digital library of ancient documents. Next, programmers, with the assistance of linguists and historians, developed the necessary algorithm for analyzing the cuneiform texts. Test results showed that AI translated the ancient texts with 75% accuracy. Moreover, the program successfully restored damaged tablets, reconstructing lost text. This result demonstrated the effectiveness of software in working with cuneiform texts. Turkish researchers now plan to use AI to decipher the remaining tablets. Today, many ancient languages remain unstudied due to a lack of information about their vocabulary, grammar, and syntax. However, even a small number of inscriptions may be enough to learn how to decode texts in extinct languages. While this seems impossible to some scholars, programmers from the Massachusetts Institute of Technology are confident that their new AI can work with ancient, unstudied languages. Additionally, the program will not only translate texts, but also identify the linguistic relationships between the studied language and other known languages. The AI operates on basic linguistic principles. Its decryption algorithm learns to map the sounds of a language into a multidimensional space, where differences in pronunciation are reflected as distances between corresponding vectors. This approach allows researchers to trace language evolution and compare words in ancient languages to their modern equivalents. Programmers began testing their algorithm on the Iberian language, which was once spoken in the Iberian Peninsula, modern-day Spain. For comparison, they examined several linguistic groups. The Basque language and Latin were found to be the closest to Iberian, but the study revealed they were not directly related. Researchers are now working to expand their decoding approach using cognate words, hoping to find a linguistic family for the Iberian language. The Dead Sea Scrolls, also known as the Qumran manuscripts, were discovered in 1947 in the caves of Qumran, located a few kilometers from the Dead Sea and the Jordan River. These scrolls date from the 3rd century BCE to the 1st century CE and are significant religious, historical, and linguistic artifacts, as they contain fragments of the Bible written in Qumran Hebrew. Following this discovery, archaeologists found many similar manuscripts containing biblical texts in other Judean caves. For a long time, it was believed that each of the first scrolls discovered was written by a single individual. Scientists from the University of Groningen in the Netherlands decided to test this theory. They analyzed one of the Qumran scrolls containing 66 chapters of the Book of Isaiah, using AI trained to distinguish ink from the parchment and analyze each character for minute variations. The analysis revealed a break at the end of the 27th column of text, after which the character style changed, indicating that the scroll was written by two different individuals. This finding disproved the theory that the scrolls were created by a single person. Researchers involved in this project believe that entire teams of scribes worked on the manuscripts. The Archimedes Palimpsest is an ancient manuscript containing unique texts by Archimedes that are not found anywhere else. The manuscript, written on parchment in the 10th century CE, was discovered in the early 20th century and continues to be intensively studied by scientists today. The challenge of working with the manuscript lies in the fact that part of the text was damaged by acid, and a previous owner had supplemented the manuscript with 4 Byzantine-style miniatures in this area, rendering the original text illegible. Scientists had long tried to restore this fragment, as its absence undermined the meaning of the entire manuscript. In 2005, Uwe Bergmann discovered that the ink used for the palimpsest contained an iron-based pigment. He proposed using X-rays to restore the text, as traces of such ink fluoresce under irradiation, allowing sensors to capture the erased text. This approach succeeded, and scientists restored part of the erased text. However, its quality was poor and barely legible. To complete the restoration of this valuable manuscript, a specially designed computer program was employed. Its algorithm enabled the restoration of damaged text and its translation into English. Thanks to this meticulous work, researchers managed to read most of the unique scientific works of the ancient Greek scholar Archimedes.